So now we're going to look at polynomials with inequalities. So again, what is an inequality? Just to recap, an example would be 0 is less than 1. So anything x is greater than or equal to 3. So less than or less than or equal to, greater than or greater than or equal to. What is a linear inequality? So linear just means that it takes the form of y equals mx plus b, but this would be an example of a linear inequality. So an example would be 2 is greater than or equal to 5x minus 7. So what are some methods that we can solve linear inequalities? Well, the same principles apply as solving polynomial equations. So we can solve it graphically or algebraically. And also a key thing to remember is that if you're dividing or multiplying by a negative, you want to flip the inequality. So for our first example, we want to solve the linear inequality 3x minus 1 is less than 8. So here, the red function is the left-hand side, 3x minus 1. The blue function is just y equals 8. So we have our blue function, our red function. Where do they intersect? Right over here. And that value would be 3. And where does it exist? So where is the red function less than the blue function? So that would be anywhere here. So therefore, x is less than 3. Now let's solve it algebraically. So we're going to move the negative 1 over to the right-hand side. So 3x is less than 9. So you're just adding the 1 to the other side. And so we're dividing by 3. X is less than 3, which is the same as the answer we got graphically. So we know it's correct. Okay, now let's solve this graphically and algebraically as well. So we have 35 minus 2x is greater than or equal to 20. So I've taken the left-hand side is the red function, and that's just this line. And then the right-hand side is equal to 20, so y equals 20 is right here. So we want to find our point of intersection, which is right here. And that is about 7.5. And then where is the red function greater than the blue function? So that is here. So then we know that our solution is going to be x is less than or equal to 7.5. Now it's less than or equal to instead of just less than, because in the question it's less than or equal to. So if it's stated in the question, you want to also mirror that in the answer. Okay, so let's solve this algebraically. 35 minus 2x is greater than or equal to 20. So I'm going to bring over the 35. We get negative 15 on this side. And now we need to divide by a negative. So here's where we're going to flip the inequality. So it's going to turn to less than or equal to, and 7.5 is 15 divided by 2. So that is the same as what we got up there. Okay, now let's do a trickier example. So we have 30 is less than or equal to this function here, which is less than or equal to 46. So it looks like the upper bound is 46, the lower bound is 30. So we've graphed 46 is our green, 30 is our red, and our function, which is linear, is your blue. So we want to figure out our point of intersections. So here it looks like at 5, and then there's one at 9 here. So it looks like our function exists between those two boundaries in this highlighted area. So therefore, we'd have 5 to 9. Okay, so how do we solve this algebraically? We need to first expand that middle portion. So we get 6x plus 12 minus 2x minus 2 is less than or equal to 46. And now collect like terms. So we get 4x plus 10 . Okay, so now what do we want to do? We want to bring this 10, we want to get rid of that so we can isolate x. So first thing we want to do is when you have this situation, we want to do it on both sides. So we're going to subtract 10 from here, and we're going to subtract 10 from here. Okay, so that gives us 24x is less than 36. And now we need to do the same thing with the dividing 4. So we're going to divide both sides by 4. So 20 divided by 4 will give you 5. And 36 divided by 4 will give you 9, which is what we got above. So just to summarize, when we're dealing with inequalities, we take the same approach as we did when we solved polynomial equations. So we can solve graphically or algebraically. We need to flip the inequality if we're dividing or multiplying by a negative. If you're dealing with a double inequality, you must complete the same operation in each part of the inequality, so the left-hand side and right-hand side. And then linear equations give you one solution, linear inequalities give many solutions.